let's demonstrate on a simple example, daemon versus non-daemon, as well as the join method and what does it influence. So first of all, we import threading and time, and here's our worker function, which will provide as a target to our thread. We will have a single thread, well, the main thread, and then a single additional thread. And inside this additional thread, we will iterate in loop 5 times. So this is short-lived thread, or it's supposed to be a short-lived. It has a very specific task, and then at some point it should finish, which is a good candidate for joining, but we'll reach it in a second. And from the thread, we should see those print statements, which will be printed by the worker thread, not by the main thread. And then after each print statement, it would sleep for, or it should sleep for 1 second. And from the main thread, we will see, first of all, that it's starting, and then that it's finished whenever it reaches the end. And here are a couple options. Yeah, so we create a thread, provide a target, daemon set to false, which is default, but we'll switch it to true to show you what will change. And each thread has to be explicitly started, but doesn't have to be joined. We can start a thread. Without start, nothing will happen. Maybe this is the very first thing that we'll show. Yeah, so if we don't start, this worker thread will not do anything. It will not enter the run method. And the only thing that we really did is print the main thread starting and the main thread finished. But when we start, the main thread is finishing already here after the worker printed the first statement. The main thread has finished here, and then the worker running 1, 2, 3, 4 was still able to complete everything. And this is non-daemon thread, which is started but non-joined. But if we join it, then what will happen? The main thread is starting, and it's finishing after the worker thread has finished everything. So we can, and by joining, we will prevent the main thread from finishing before all the workers have finished their work. And now, what happens if we set the daemon to true? We will be able to only print it once. Try again. Not even new line has happened. And try again, and so on. So most of the time we'll be able to print it once, but then immediately after that, the whole program or the whole process finishes with exit code 0. So the main thread finishes and doesn't wait for the either daemon versus non-daemon thread as long as you are not joining. If you are joining, that it will wait for both, but the whole process will keep running when you still have non-daemon threads. But if you have just daemon threads, then it finishes, it doesn't care about them. So the daemon are like less priority, lower status threads. And then finally, if you do join, everything works the same as if it was non-daemon. So this daemon flag, whether it influences anything at all, depends strictly on the rest of the code. On its own, just signals that it's a lower priority, or if there are only daemons left, then the whole process will exit. But if there are only daemons left, but you are still you join them and you wait for them in the main thread, then the whole process will keep running, because they are still joinable. And this is something different than the idea of detached thread in C++, which is an opposite of join, and you cannot join a detached thread.